We have seen the perimeter security, which is on the VNet level. On the other side, it is also on the IP address and website level. What about on the port level? For that, we do have something called NSG, Network Security Group. And in AWS, you call it as Security Group. VNet, you call it as VPC. NSG can be applied on only two different places. The first one is on the subnet level, and the second one is on the VM's NIC level. But we have created many virtual machines, but we haven't spoken about NSG. Create a virtual machine and click on that resource group and see all the dependent services. We have operating system disk, we have public IP, we also have something called NSG. Do you remember while creating a virtual machine, we enable port number 80, 443 and 3389 or 22. These two are for remote desktop. When we enable these ports, Microsoft Azure clubs all of them into one particular group and calls it as Network Security Group. Now, a combination of these two together forms the complete NSG rules. But what is this NSG rule? It is called 5-tuple hash. It works based on 5-tuple hash. What is this 5-tuple? Together, all these are 5-tuple hash. I have my source IP and source port, destination IP and destination port, and the protocol through which I'm going to communicate. Now, source and destination is purely dependent upon where exactly we are communicating from and to. Let's say this is one subnet S1 and we have a virtual machine within this. I want to do internet communication from my machine. Here is my machine. When I do internet communication with this particular virtual machine, my source is my laptop and my destination is the particular virtual machine. And from this virtual machine, assume that if I have logged into this virtual machine and I want to take a remote desktop via 3389 to my laptop. In that case, from here, I'm logging into my laptop. The destination becomes my laptop and source becomes the virtual machine. Now, how 5-tuple hash works? Let's take two different examples. This is the subnet and we have a virtual machine. Let's say this is my another computer wherein I want to take a remote desktop. For remote desktop, we need port number 3389. This is for Windows. We also need port number 22 for Linux. Let's look at few other port numbers if you are new to networking. Port number 80 and 443 is for HTTP and HTTPS for internet connection, and 1433 is for SQL database. From my laptop, I want to do a remote desktop to the virtual machine. So there are two toll gates here. The first toll gate is on the subnet NSG level. The second toll gate is on the virtual machine NICOD's NSG level. On the NSG of the subnet level, 3389 is disabled. But while creating a virtual machine, I have enabled 3389, 80 and 443. Can I do a remote desktop to this machine? The answer is no, because here is the flow. The flow comes here, and since 3389 is disabled, the communication terminates here. Now for this, I need to enable this port and then it can come into the virtual machine. Let's take one more example. In the previous example, we have spoken about remote desktop, and here we will speak about internet, which is port number 80 and 443. Here is my laptop. This virtual machine is a web server and I want to access the website. Port number 80 and 443 is enabled on the NSG of subnet level, but 80 and 443 is disabled on the virtual machine level. From this laptop, can I do the internet access to my web server? No. From this virtual machine, can I do the internet access to the laptop? No. So in order to establish internet connectivity, I need to enable port number 80 and 443 on my virtual machine. So it has to be on two different toll gates. The first one is the NSG of subnet. The second one is NSG of the NIC of virtual machine. Now, where can I add these? Let's go back to our portal and see where exactly can I add. Now, I'm on the portal and I want to apply NSG to this particular subnet. I need to hire a new resource, which is network security group. Do not choose the classic one. This is for old portal. We are in ARM, so we have to choose network security group. You need to put it in the same resource group and it has to be in the same region. I'm going to call it as NSG1. Create the NSG. Once the NSG1 is created, we have to go into that NSG and we need to make edits on inbound and outbound rules, which is nothing but the source and destination. My NSG is created and do you see the inbound and outbound rules? But by default, there are some rules which are given by Azure. For example, inbound, which means any outside traffic which is coming into my virtual machine. By default, deny all inbound. By default, allow all VNet inbound and also load balancer communication. If you see the outbound rules, which mean from my virtual machine to the outside world, there are some basic rules and we cannot really mute those rules. Probably you can hide those rules, but we cannot really mute it. Here I'm going to add a particular rule. Do you see the 5-tuple hash? Source IP, source port, destination IP, destination port, and the protocol. Once we choose this, then it is your decision to allow or deny. Now we do have some priority numbers here. Remember this thumb rule, higher the priority number, lower is the priority. So here when I am adding a new network security group rule, I need to give a very low priority. It is usually between 100 to 4096. If you give 99, it says it is always between 100 to 4096. So source IP address, it can be the service tag or application security group, but I'm going to give any and then the wildcard entry, any source port from any source IP. Destination also can be any because I'm going to apply it on a particular subnet. So any IP address in that subnet can pick it up. But here is where it is the most important thing. 3389, which means that is the particular port number. You can also give 80, 443, 1433, multiple port numbers that I want to allow. Protocol, I'm going to give it as any and allow or deny. Here I'm going to allow all the communication. And we see the warning because it should not be exposed to internet, but ours is a testing purpose. So give a name. And also you can give the description. Once this is done, while this is going on, we are also going to add the same in our outbound and understand that it's not necessarily you have to add the same in the outbound. It purely depends upon the business purpose. And you can use the same priority number. So this is a common example in many of the organization. We will discuss one practical scenario. This is one subnet and there is a particular server in the organization and there are n number of employees in the organization. Let's assume that everybody knows the IP address of this particular server. Can they do a remote desktop? Yes, all you need is an IP address. So here we need two different rules. The inbound rules, which has to be different, and also the outbound rules, which are totally different from inbound. Anybody from this organization cannot do an RDP, which means 3389 must be blocked, 22 must be blocked. But from this server, I can take a remote session to any of the employees' machine, which is very common in many of the organization. So I can enable 3389 and port number 22 in the outbound rule. Do you see the inbound rule is totally conflicting with the outbound, but that's perfectly complementing my business requirement. This is one such example. Let's go back to our portal. So we have added the particular rules. Now we need to once again go to virtual network and click on that particular subnet. When you click on that subnet, you have something called Network Security Group. And I do see NSG1. Apply and save. So creation is the first step and application is the second step. Remember, when we create the data disk in the virtual machine, we created it first and then we did the mounting. It's similar. So when you're doing these activities in the exam, do it completely. So we have enabled this particular subnet with the network security group. We have one more thing called routing table. Now, what is routing? Let's go to whiteboard and we will understand. There are two different types of routing in Azure. The first one is system routes, which means anybody can talk to anybody by default within a VNet. I have a VNet and I have three subnet S1, S2, S3. S1 can talk to S2 and S3. S2 can talk to S1 and S3. And they are all in one VNet and the thumb rule is anybody can talk to anybody within a virtual network. But my requirement is I need to make some changes in the routing policy here. Is it allowed? Yes, that is nothing but your user defined routes. And when is it useful? Let's take an example that 3 is a particular subnet. Anybody who comes to subnet number 1 must go to 3. It can go to 3 by default, but it's not necessary that it will. So I need to make it as a rule that anybody who is coming to 1 must go to 3. Or I can draw one more quick architecture here. This is a VNet and I have S1 and S2 as subnet. I am renting something called VNA, Virtual Network Appliance, and I am going to make that as a third subnet. And here I have firewall. If you feel that, of course, on the VNet also I have firewall as a service, but many customers feel that it is a bit expensive and they want to have their own firewall, you can rent it from the marketplace. And you need it in the form of a virtual machine, which is a VNA. In that case, anybody who comes to S1 and anybody who comes to S2 must go to VNA subnet. I'm going to call it as VNA subnet. We can do this type of routing. For this, we need the route table, and route table is always for the destination to VNA subnet. And I can assign it in any of the source. I can assign it here, I can assign it here. I'm going to call it as RT1 and I can assign RT1 in the S1 subnet. And in future, if I'm creating S3, S4, S5, anywhere I can apply my RT1. But in one subnet, I can always assign one NSG and one RT. Let's take a very practical example that I want to go to London and there are many other people who are also coming to London. It doesn't matter where they are. The 2 in their ticket always shows, or the destination in their ticket shows London. So here also it is the same thing. It is almost like the ticket that we are buying only for the 2. And wherever I want, I can apply it. Now let's quickly go back to portal. We will try to create one more route table, but that is a separate resource that I have to hire. Here also I have to create a route table and then I need to apply it. And it must be in the same resource group, same location. So my VNet is in West US. My route table is done. Here, this is the page. I need to click on route and here I'm going to add 2. But I have only one subnets. So can we do one thing? We'll quickly create 2 other subnets. That is a good practice for us also. Here's my VNet. I have only one subnet. So let's create 2 more subnets. That's a good practice for us as well. Let's assume this S3 has the virtual network appliance. In that case, in my route table, I will give a route name and the address prefix has to be my S3's address prefix, which is 10130/24. I have typed in the address prefix, and the next hop, I'm giving it as virtual network. My route table is ready. The destination is S3, so I'm going to S1 and S2 and apply the route table. My RT1 is ready here. I have applied it on the S1. It's done, and I'm going to S2 and I'm going to S2 and apply S3's routing table. We also have another security component. There are three virtual machines and my application is spread across three virtual machines. Instead of securing the complete VNet and the complete subnet, I want to save only the application. There we need to use application security group. I'm grouping all the VMs together and I'm applying the ASG. And this also comes with Web Application Firewall. This is a layer 7 protection. During the introduction of networking lecture, we have seen public IP address and private IP address. In Azure, these are some of the places wherein we can see public IP address, and you can also check if it is dynamic or static. And this is the public IP address list. For example, virtual machine NIC. I have both public IP address, and in the next page, I do have the private IP address also. I have the load balancer, which is the public load balancer, which has the front end IP configuration with public IP and the rear end is always private IP. So take a screenshot of this page, which is under public IP address, and also the private IP address, which is very important from the exam perspective and also for your day-to-day job. And what is static and dynamic? Every time you restart a virtual machine, it asks you if you want to reserve the public IP address. So if you are very sure that this virtual machine is very important for you, that you are going to assign a set of roles and responsibilities for that VM, then please make the IP static. Go to networking in that virtual machine, click on the NIC IP address and then make it static. It's always a best practice to make the IP address static if it's a very important server. For testing purpose, it doesn't matter.